Hi, it's a great pleasure for me to introduce you myself and my work within the SUP&R project. My name is Emina Balic, and in following few minutes I will introduce you my work. First, give me a few seconds to tell you something about myself. I come from a small country from Balkan, Bosnia and Herzegovina. There I obtained bachelor's and master's degree in civil engineering at the University of Sarajevo. Also, I have gained industry experience as an associate engineer in geotechnical projects for road infrastructure. But where am I today? In September 2014, I moved to Ireland and started working as an early stage researcher number 11 within the SUP&R project. My new workspace in Dublin is at University College Dublin. At UCD, I am doing my PhD. My supervisor at UCD is Dr. Kieran McNally, and the project is also having some collaborative work with Irish Rail and Queen's University Belfast. Now it's time to introduce you the project more. In railway infrastructure, we want to prevent scenarios like shown on the pictures in the upper side of the slide. What we see here is a collapse, total failure in the base of our railway. Usually, these failures are a result of different degradations in the base of our track that is made of ballast beds, subballast and subgrade. The project is looking for a solution to help railway engineers to identify early signs of these degradations. We want to help them to locate on time weak spots along and across the railway track so the maintenance operations can be done where required. The main objective of the project is detection of the weak spots along and across the railway track. How will we do it? With combination of numerical modeling and field lab work on railway track or on its elements, we will detect the weak spots in the base of the railway track. In this regard, it is of great importance to have constant monitoring of the railway foundation, ballast, subgrade, and underlying layers. The methodology we are using for monitoring is the combination of different numerical models and vibration-based testing of railway track. The equipment we use for experimental and field work includes sensors such as accelerometers, laptop, data logger, power supply, and an excitation source such as instrumented hammer or even train signals. On the other side, numerical models are built in MATLAB and finite element software Abacus. The different health conditions of the underlying ballast and subgrade will influence the behavior of the railway track elements, rail and sleeper. For instance, assume that there is a degradation in ballast layer at this location underneath the sleeper. If we excite the railway sleeper, record the response and post-process the data, we can see that plotted mode shapes for lower frequencies and plotted frequency response functions differ from the case when there is no change in the sleeper support. This is encouraging us to go further. Evaluate the behavior of rail and sleeper along and across the track for different conditions in the ballast bed and subgrade layer. Find a link between the behavior of rail and sleeper and corresponding condition present in the base of the track. When we make the connection between the response and condition, we will solve the inverse problem, locate and quantify the severity of the change present in railway substructure. At the end, this will enable us to act on time and act on exact location where maintenance is required. By this, we will increase the sustainability and the total lifespan of our track. All the work has been undertaken as part of the Marie Curie Initial Training Network action. Thank you for your attention, and if you have any interests, questions about the topic and about the project, please do not hesitate to contact myself or my supervisor. Here you have all the contact details. You can also follow me on Twitter, ResearchGate, and follow the updates of the project on the websites shown. Thank you once again.